Welcome. In this video, we'll take a look at an indefinite integral involving the exponential e to the x function. So let's consider what we have. We have the integral of 1 over x squared minus e to the negative x plus 2 divided by e to the negative x. So this looks very complex at the onset, but I assure you this actually can be broken down pretty quickly with just our algebraic rules. So let's consider rewriting this expression. We'll start with the first term, 1 over x squared. If I wanted to rewrite this inside my integral, I can express this as x to the negative second power. And that will be a little bit easier to work with my antiderivative rules. Next, I can take a look at the e to the x mess that we have in the second term here. Notice that we can actually divide each of these terms by e to the negative x. So there's two terms here, so I'm going to kind of bracket this off. I'll have e to the negative x over e to the negative x plus we'll have 2 over e to the negative x dx. We'll see some nice things happening here in the second term. E to the negative x and e to the negative x will become just 1. And then I can bring the e to the negative x into the numerator and write it as a positive power when I rewrite for a final time. So let's rewrite our integral one more time before we take the antiderivative. We have x to the negative 2. We'll have a minus sign distributing here, minus 1, and then minus 2. And that e raised to the negative x, we can bring into the numerator as a e raised to the positive x power. And then we'll have our dx. So we have 3 terms here we want to take an antiderivative of. So let's go out and do that. The first one just uses a power rule, so we're going to say x raised to, the original power is negative 2, so we're going to add 1 to the power, making it negative 1, divide by my new power. The next term is negative 1, so I'll have negative 1, and then remember this has an x to the 0 power sitting next to it, so we'll raise the power by 1 and just becomes x to the first power times 1. And then the last term, we notice that e to the x is in our integral, and if we consider just the integral of e to the x by itself, dx, we know that the exponential function e to the x is its own derivative. Therefore, it's also going to have to be its own antiderivative. So actually, let me write it properly here. E to the x plus c would be that antiderivative. So here we're just multiplying this by a constant, so negative 2 integral of e to the x is just e to the x. And again, everything collectively we can add a plus c to for that integration constant. So we can write it one more time here. If I rewrite this first term, that'll be negative 1 over x to the first power minus x minus 2 e to the x and then plus c. And that will be our final result there with positive exponents. So something that started as a pretty complex integral, we could break down just using our algebraic techniques and then using our power rule for antiderivatives. So I hope this is a helpful example for you to think about how to problem solve in indefinite integrals. Hope to see you in the next video.